So looking at question 3 here, we've got 20 minutes proposed or a suggested time. Only accept numbers 1 to 20 inclusive. Invalid input if it's outside of that. Number followed by is even. Number followed by is odd. So I've got my question 3 finished, ready to go. And the first thing that I notice here is it's talking about fixing a runtime error because of a valid number. So I'm spotting here that this num will be a string. So we need to coerce that to an integer. So that's the first thing I'm going to do. Int. So now num is going to be in the right sense. Fix a logic error that caused no outputs for acceptable. So the other thing I notice here is we've got in integer divide here. I'm going to go for modulus because that's the classic test for odd and even. So if the remainder is 0, modulus 2, and then else print so I think that fixes the logic error for testing for odd and even correctly. Next thing is yeah, we need to restrict it to numbers between 1 and 20 inclusive. So I'm going to if num greater than or equal to 1 and num less than equal to 20, I'm going to go into this if loop. So if the num is not in this range, I'm going to print invalid input. So let's have a go. We'll try saving that and running it. Input a number. Let's try 4 is even. Run 7 is odd. Run 22 invalid input. So it doesn't look too bad. Make all match statements at this. Do not add any additional functionality. So I don't think that's far off. I'm going to put some comments in here. Maybe just open that up a little to make it more readable. So if we look at the mark grid, you can see that we've got the color coding here to match up with the assessment objectives. So coercion of input gets you a mark, fixing errors by using modulus rather than integer divide. The validation would get me to correct Boolean operator, use of and rather than or, get you 1, and the correct output messages. And now the level-based mark scheme will donate up to 6 marks for this question. So let's have a quick look at that. So solution design will be if it's clear and appropriate logic to the problem, and then the functionality is if it works. So ostensibly here you could get 3 marks for a completely fully working solution, even if the solution design has been very unclear and ill chosen functions. And one could have used the integer divide and test that what was left was a whole number rather than floating and such like. It would have been over the top and not elegant and not a good solution design. So this result would have given the full 13 marks.